Is it the screen is visible to all?
Yes, sir.
Okay. Wait a minute. एकच मिनिट थांबा. Okay. Now is it visible?
Yes, sir.
Okay. So in the previous lecture, we seen that the theorem, okay, in which इथे काहीतरी डाऊट होता आपल्याला. Okay. Now look at here. How there is VK comes. Okay. Now look at here. This is the differential equation of order n minus 1. Okay. This is the differential equation of order n minus 1 by dividing phi 1 to this equation. Okay. जर या इक्वेशनला आपण phi 1 ने डिवाइड केल्यानंतर काय होणार आहे? Differential equation, ordinary differential equation, homogeneous differential equation with order n minus 1. Okay. Now we assumed that V2, V3, Vn are the linearly independent solution of the differential equation in V of order n minus 1. If suppose V2 is the solution, okay, so we put in, instead of V, we can put here V2. Similarly, instead of V, we can put here V3. Okay, so in general, we can write VK. Okay, जर V2, V3, Vn हे जर सोल्युशन असेल तर काय करणार, हा तुमचा डिफरन्शियल इक्वेशन सॅटिस्फाय करणार होतो. Okay, of order n minus 1. So in general, we can write Vk raised to n minus 1 plus Vk raised to n minus 2 of, this is the coefficient of Vk. Okay, these are coefficients phi 1 n into phi 1 dash plus n minus 1 into phi. Okay, कळते का? Okay, and the next point we seen the basis. What is the basis? If phi 1 phi 2 belongs to yes and c1 phi 1 plus c2 phi 2 belongs to yes, then set yes is called as the linear space. Okay, that is vector space of functions. If a linear space yes contain n functions phi 1 phi 2 up to phi n, which are linearly independent, and every function from S can be represented by linear combination of phi 1, phi 2 up to phi n, then the set S is called what? The basis of that linear space. Okay, this set spans this vector space, yes. Okay, linear space, yes, and this set is linearly independent. Hence, this set is called as V basis. Okay. Now, the next point is Roskin and independence. The next point of our syllabus is the Roskins and linearly dependent. Roskin and linearly independent. आवाज ऐकू येतोय माझा?
Yes, sir.
Okay. If phi 1 phi 2 up to phi n, if phi 1 phi 2 up to so on phi n are n solutions of L of y, n solutions of L of y is equal to 0, which is equal to y raised to n plus a1 of x into y raised to n minus 1 plus up to so on an of x into y. Okay, on an interval I. Okay, then they are linearly independent. They are linearly independent on I if and only if Ruskin of phi 1, phi 2 up to so on phi n of x is not equal to 0 for all x belongs to I. Okay, his theorem. This is the theorem. Okay, theorem the statement ends. We seen this theorem for homogeneous linear differential equation with constant coefficient. Now here the homogeneous linear differential equation with variable coefficient. Okay, so we have to prove that these phi 1, phi 2 up to phi n are linearly independent if and only if rho skin of their rho skin is not equal to 0 for all x belongs to I. Okay, any doubt?
No, sir.
Now the proof of this theorem. Suppose, first part, suppose the rho skin of phi 1, phi 2 up to so on phi n at point x, at any point x is not equal to 0 for all x belongs to I. Okay, we have to prove that phi 1, phi 2 up to phi n are linearly independent. Okay, now suppose there are constant, there are n constant, there are n constants C1, C2 up to so on Cn such that C1 into phi 1 of x plus C2 into phi 2 of x plus up to so on Cn into phi n of x is equal to 0 for all x belongs to I. Okay, if I have to prove that this phi 1, phi 2 and phi n are linearly independent. For this, we consider the C1 phi 1 plus C2 phi 2 up to Cn phi n is equal to 0 if all the Ci's, all the coefficients of all phi 1, phi 2, all the coefficients of phi 1, phi 2 up to phi n, that is C1, C2 up to Cn are 0, then we say that these phi 1, phi 2 are linearly independent. Okay, that's why we consider the C1 phi 1 plus C2 phi 2 up to Cn phi n is equal to 0 for all x belongs to I. Okay, now differentiate this equation with respect to x n minus 1 times. Okay, so differentiate with respect to x up to n minus 1 times. Okay, so what we get? C1 phi 1 dash of x plus C2 phi 2 dash of x plus up to so on Cn phi n dash of x is equal to 0. Okay, now second one, second time C1 phi 1 double dash of x plus C2 phi 2 double dash of x plus up to so on plus Cn phi n double dash of x is equal to 0. Okay, up to so on, we get n minus 1 times, hence C1 phi 1 raised to n minus 1 of x plus C2 phi 2 raised to n minus 1 of x plus up to so on. Cn phi n raised to n minus 1 of x is equal to 0. Okay. So this is the linear equation. Okay, and linear system of equations. Okay, this is the system of linear equations. So this system of linear equations we can write in the form of matrix form. Okay, so the above system of equation we can write as in the matrix form. Okay, this one. Phi 1 of x, phi 2 of x, up to so on, phi n of x, phi 1 dash of x, phi 2 dash of x, up to so on, phi n dash of x. At the last, phi 1 raised to n minus 1 of x, phi 2 raised to n minus 1 of x, up to so on, phi n raised to n minus 1 of x. And this one is the column vector is C1, C2 up to Cn. Okay, which is equal to the right hand side is 0, 0 up to so on 0. Okay, any doubt?
No, sir.
Give it as an equation number 1. Now, since the determinant of coefficient matrix, the coefficient matrix of system above system is row skin of phi 1, phi 2 up to so on phi n of x. Okay. Therefore, matrix is invertible. Okay, जर determinant तुमचं not equal to 0 असेल तर काय होतं? The coefficient matrix is invertible. The coefficient matrix is invertible. Okay, so on pre-multiplying by inverse of coefficient, inverse of what? Coefficient matrix, we get right hand side ला काय, left hand side ला only the column vector येईल ना, C1, C2 up to so on Cn. Okay, and right hand side ला pre multiply काय करतोय, post multiply काय नाही, इकडे pre multiplies काय करतोय,
प्रोडक्ट पोस्ट
post multiply
मल्टिप्लाय
काय
केलं
नाही
तर मॅट्रिक्स
जर इथे
मल्टिप्लिकेशन पॉसिबल नाही.
पॉसिबल नाही. तर इथं मी n क्रॉस n चा पोस्ट मल्टिप्लाय केला इकडून या साईडनं. ओके, पोस्ट मल्टिप्लाय केला तर हा प्रोडक्ट तुमचा होणार नाही. ओके, आणि पी मल्टिप्लाय केल्यानंतर काय होईल माझा n क्रॉस n मॅट्रिक्सचा, इथे हा तुमचा प्रोडक्ट पॉसिबल होईल. ओके, दॅट्स वाय वी मल्टिप्लाय प्री मल्टिप्लाय. ओके, so here we get 0, 0 up to so on 0, which implies C1 is equal to C2 is equal to up to so on Cn, which is equal to 0. Okay, that is if summation running from I is equal to 1 to n, Ci alpha I of x is equal to 0, It implies C1 equal to C2 equal to up to so on Cn, which is equal to 0. Okay, hence phi 1, phi 2 up to so on phi n are linearly independent. Okay, now converse part. Conversely, assume that assume that the phi 1, phi 2 up to so on phi n are linearly independent on I. Okay, for any point x belongs to I. To prove that, the row scheme of phi 1, phi 2 up to so on that phi n at point x is not equal to 0 for all x belongs to I. Okay, so suppose the contradiction. Suppose we have to prove this one for all x belongs to I, the row scheme is not equal to 0. Okay, so suppose there exists a possible, there exists a point x now. Suppose, if possible, the check cashless, if possible, assume that, okay, assume that there exists a point, exists a point x naught belongs to I such that the row scheme of phi 1, phi 2 up to so on phi n at point x naught is equal to 0. Okay, so it implies equation 1 becomes at x is equal to x naught. At x is equal to x naught, equation 1 becomes असं पाहिजे. Okay, आधी हे स्टेटमेंटला मग हे लिहा. At x is equal to x naught, equation 1 becomes what we get. Equation 1, a system of equations in the matrix form. Okay, phi 1 of x naught, phi 2 of x naught at up to so on phi n of x naught, phi 1 dash of x naught, phi 2 dash of x naught up to so on phi n dash of x naught up to so on phi 1 raised to n minus 1 at point x naught, phi 2 raised to n minus 1 at point x naught up to so on phi n raised to n minus 1 at point x naught. Okay, and this is the column vector as it is, c1, c2 up to so on cn, which is equal to 0, 0, and this one is 0. Okay, any doubt up to here? Since the determinant of coefficient matrix is row skin of phi 1, phi 2 up to so on phi n at point x naught is equal to 0, and we have okay, since the determinant of the coefficient matrix is what? Row skin of phi 1, phi 2 up to phi n at point x naught, which is equal to 0. Okay, this is the coefficient matrix. So we have row skin at x naught is equal to 0. Okay, therefore the system of equation possesses जर त्याचा डिटर्मिनंट 0 येत असेल तर त्याची रँक काय असणार? लेस दॅन n असणार. लेस दॅन n असेल तर काय होणार? possesses non trivial solution. Okay, any doubt?
No, sir.
That is at least one of the constant, one of the constant Ci, okay, which constant Ci are non-zero. Okay, let Ci in bracket लिहा. Ci is not equal to 0 for some I. Okay, let आता फक्त सी आय नॉन झिरो आलाय. कोणता तरी एक सी आय यातला काय असायला पाहिजे तुमचा नॉन झिरो असायला पाहिजे. बट वी हॅव टू प्रूव्ह दॅट द लिनियर कॉम्बिनेशन विथ फाय वन फाय टू सी वन फाय वन सी टू फाय टू सी एन फाय एन इज इक्वल टू झिरो. हे आपण आधी अजून प्रूव्ह केलेलं नाहीये. ओके, आधी ते प्रूव्ह करावं लागेल. सी वन फाय वन प्लस सी टू फाय टू प्लस सी थ्री फाय थ्री इज इक्वल टू झिरो. It implies at least one of these constant is not zero. Then we say that the functions phi 1 phi 2 are dependent. Okay, अजून आपण ते प्रूव्ह केलेलं नाही. ओके, फॉर दिस लेट c1 c2 up to so on cn be such a solution. ओके, जे काही तुमचे c1 c2 येतील या अबो मॅट्रिक्स मध्ये such a solution, ते सोल्युशन घेतले and consider the function. Which function? Psi. Consider the function psi of x is equal to c1 phi 1 of x plus c2 phi 2 of x plus up to so on cn phi n of x. ओके, जे कोणी जे नॉन ट्रिवियल सोल्युशन असतील जे आलेले C1 C2 त्याच C1 C2 Cn ला घेऊन मी एक फंक्शन डिफाइन केलाय. ओके, psi of x is equal to C1 phi 1 plus C2 phi 2 up to Cn phi n. Okay, since phi 1 phi 2 up to so on phi n are solutions of L of y is equal to 0, therefore their linear combination, c1 phi 1 of x plus up to so on cn phi n of x is also solution of L of y is equal to 0. Okay, we know that if phi 1 phi 2 up to phi n are the solution, then their linear combination also is the solution. Okay, therefore psi is the, what is the linear combination? Is nothing but psi of x. Psi is the solution of L of y. Solution of L of y is equal to 0. Okay, and also what is psi of x naught? Put x is equal to x naught. Here we get c1 phi 1 of x naught plus c2 phi 2 of x naught plus up to so on cn phi n of x naught. Okay, now look at here. Wait a minute. Okay, psi of x not 0. From above system of equation. Okay, so this is psi of x naught is equal to c1 phi 1 of x naught, c2 phi 2 of x naught, up to so on cn phi n of x naught. And also the psi of x naught is equal to 0. Okay, psi of x naught is equal to 0. It's 0 कशाला from above system of equation म्हणते. ओके, हा psi of x naught कसा येईल ह्या नंतरच्या लेक्चरला सांगेन मी. ओके, psi of x naught is equal to 0. ते रिझन दिले फ्रॉम above system of equation. Okay, from above system of equation म्हणते reason since. ओके, ते नंतर सांगेन कसं येईल. psi of x naught is equal to 0. Similarly, psi dash of x naught is equal to c1 phi 1 dash of, okay, याला म्हणजे हे केलं differentiate. So here we get psi dash of x naught is equal to 0, which is equal to psi double dash of x naught. Okay, psi double dash of x naught is equal to, okay, up to so on psi triple dash of x naught, which is equal to 0, up to so on psi raised to n minus 1 of x naught. या सगळ्यांची व्हॅल्यू 0 येते. Okay, hence we have norm of naught bracket square up to so on mod of psi raised to n minus 1 of x naught bracket square whole bracket raised to 1 by 2, which is equal to 0 plus 0 plus up to so on 0. Okay, from these equations. So here we get 0. So this is norm of psi of x naught. Okay, but we know that we have norm of psi of x naught into e raised to minus k into x minus mod of x minus x naught, which is less than or equal to norm of psi of x, which is less than or equal to norm of psi of x naught into e raised to k into mod of x minus x naught for all x belongs to I. Okay, which implies this is 0. 0 into e raised to k into x, 0 into something is 0. So it is less than or equal to norm of psi of x, which is less than or equal to 0 for all x belongs to I, which implies norm of psi of x is equal to 0 for all x belongs to I, which implies itself psi of x is equal to 0 function. Okay, for all x belongs to I. But what is the psi of x? Implies c1 phi 1 of x plus c2 phi 2 of x plus up to so on cn phi n of x is equal to 0 for all x belongs to I. Okay, thus we have c1, we have c1 phi 1 of x plus c2 phi 2 of x plus up to so on cn phi n of x is equal to 0 for all x belongs to I, such that at least one of the ci, one of the constant, okay, one of the constants from c1 c2 up to so on cn is non-zero. Okay, so it implies that phi 1 phi 2 up to so on phi n are linearly dependent. So which is contradiction to equation number 2. Okay. So what is the equation number 2 is this one. We assumed that converse part. Yeah. This is contradiction to 2. This is the equation 2. Statement number 2. We assumed that phi 1, phi 2 up to phi n are linearly independent. But here we get phi 1, phi 2 are linearly dependent. Why? Because we assumed that there exists a point x naught belongs to I, such that rho skin at point x naught is equal to 0. Okay. Therefore, this statement is wrong. Which statement? The rho skin at point x naught is equal to 0 is wrong. There does not exist any point x naught belongs to I. Hence, the rho skin at any point x is not equal to 0. Okay. So here we get which is the contradiction, linearly dependent. This this contradiction arises due to wrong assumption. Wrong assumption that there exists a point x naught belongs to I such that rho skin at phi 1, phi 2 up to so on phi n at point x naught is equal to 0. Okay. हे assumption केल्यामुळं हे contradiction येतोय. Hence, we must have rho skin at any point. Rho skin at any point to so on phi n at any point x is not equal to 0 for all, at any means or all x belongs to I. Okay, any doubt? Is the proof. Okay, any doubt?
No, sir.
फक्त ते साय ऑफ एक्स नॉट इज इक्वल टू 0 कसं घेतलं हे जरा कन्फ्युजन आहे मला पण. हे मी उद्याच्या लेक्चरला सांगेन. इथे साय ऑफ एक्स नॉट, साय डॅश ऑफ एक्स नॉट, साय डबल डॅश ऑफ एक्स नॉट. ओके, साय ऑफ एक्स नॉट फ्रॉम द अबव सिस्टम ऑफ इक्वेशन. ओके, हे उद्या सांगेन मी जरा. इथपर्यंत काय डाऊट आहे? तेच प्रोसिजर आहे मागच्या ज्या थेरमला घेतलंय आपण, तेच प्रोसिजर आहे रिपीट. ओके. Now the next theorem is, wait a minute. Let the next theorem is let phi 1, phi 2 up to so on phi n be n solutions of L of y is equal to 0. Okay, on an interval I, and let x naught be point in I. Then the rho skin of phi 1, phi 2 up to so on phi n at any point x is equal to exponential. Okay, exponential means e raised to power given by minus integration from x naught to x a1 of t, okay, dt into rho skin of phi 1, phi 2 up to so on phi n at point x naught. Okay, let x naught be any point in interval I, then rho skin at any point x is given by exponential to the power e raised to power minus integration x naught to x a1 t dt into rho skin at point x naught. Okay, now let's see the proof. Consider the row scheme of phi 1, phi 2 up to so on phi n at point x is given by determinant of phi 1 of x, phi 2 of x up to so on phi n of x, phi 1 dash of x, phi 2 dash of x up to so on phi n dash of x up to so on here phi 1 raised to n minus 1 of x, phi 2 raised to n minus 1 of x up to so on phi 1 phi n raised to n minus 1 of x. And this is the determinant. Okay, any doubt up to here?
No, sir.
Now differentiate w row wise. Again, the same procedure is going on. Differentiate row scheme row wise. We get w dash of okay phi 1 phi 2 up to so on phi n of x is equal to okay now first row केल्यानंतर काय होणार differentiate phi 1 dash phi 2 dash up to so on phi n dash of x, and second row is as it is phi 1 dash phi 2 dash up to so on phi n dash, and last row is phi 1 raised to n minus 1 phi 2 raised to n minus 1 up to so on phi n raised to n minus 1. Okay, plus first row as it is first row. Now differentiate second row. First row is what? Phi 1, phi 2 up to so on phi n. And first second row is phi 1 double dash, phi 2 double dash up to so on phi n double dash. Okay. Third row काय असणार? Phi 1 double dash, phi 2 double dash to so on phi n double dash. Okay. And last row is phi 1 raised to n minus 1, phi 2 raised to n minus 1 up to so on phi n raised to n minus 1. Okay, any doubt?
No, sir.
Up to so on. Now first and second row as it is, plus here. Phi 1, phi 2 up to so on phi n, phi 1 dash, phi 2 dash up to so on. This is phi n dash, and at last phi 1 raised to n, phi 2 raised to n up to so on phi n raised to n. आणि ह्याच्यावरची रो काय असणार? phi 1 raised to n minus 2. ओके, ह्याची वरची रो काय असणार इकडे? phi 2 raised to n minus 2, phi n raised to n minus 2. Now look at here. This is w dash. Okay. Now in the first determinant, first two rows are identical. Similarly, in the second determinant, our second and third row are identical. Okay, so these all these determinant are vanishes. It means the value of this determinant is 0. Value of this determinant, okay, is 0. This determinant is also 0. So only remains the last determinant. Okay. Okay. So here we get. Kai doubt आहे का? Correct आहे ना?
Yes, sir.
So in the last determinant हा तुमचा राहील फक्त आहे तसा. बाकीच्या सगळ्या डिटर्मिनंटची व्हॅल्यू 0 येईल. का? कारण की दोन रो आयडेंटिकल आहेत त्यात. ओके, फक्त लास्ट शेवटचा डिटर्मिनंट असा आहे ज्यात तुमचे कोणतेही दोन रो किंवा दोन कॉलम हे आयडेंटिकल नाहीये. ओके, सो हियर वी गेट phi 1, phi 2 up to so on phi n, phi 1 dash, phi 2 dash, up to so on phi n dash. This one is phi 1 raised to n, phi 2 raised to n, up to so on phi n raised to n. Okay, so this one is as it is. Now look at here. Since phi 1, phi 2, up to so on phi n are solution of L of y is equal to 0, we have what we have kind of is a L of y चे solution असेल. So phi 1 satisfy L of y. Okay, phi 2 satisfies L of y. L of y is what? Homogeneous differential equation with constant coefficient. Sorry, variable coefficient. Okay, so in general, I can write phi j bracket raised to n plus a1 of x phi j raised to n minus 1, a2 of x phi j raised to n minus 1, sorry, n minus 2, up to so on an, this is x, okay, an of x into phi j, which is equal to 0, okay, where j running from 1 to up to n. Any doubt? Put j is equal to 1 here. 5 raised to n, a1 of x into 5 raised to n minus 1. Okay. असे n इक्वेशन येतील ना. इन जनरल लिहिलंय मी ते. कळतंय का?
Yes, sir.
So what is the value of this one? Phi j raised to n is equal to minus sign of into bracket a1 of x into phi j raised to n minus 1 plus a2 of x into phi j raised to n minus 2 up to so on an of x into phi j. Okay, so this is equal to where j running from 1 to up to n, that is equal to phi j raised to n. Okay, it's nth derivative of phi j is nothing but minus sign of summation I running from 1 to n. Okay, ai of x into phi j raised to n minus I. Is it correct? J running from 1 to up to n. Is it correct?
Yes, sir.
Now put these values in above determinant. Okay? या ह्याच्यामध्ये ठेवा, याला काहीतरी इक्वेशन नंबर द्या. दिलं का कुठे इक्वेशन? नाही दिलं. So put these values in equation 1. So this is equation 1. Okay? So here we get W dash is equal to determinant of phi 1, phi 2, phi 2 up to so on phi n, phi 1 dash, phi 2 dash, up to so on phi n dash. Okay, up to so on. The phi 1 raised to n kind of minus summation I running from 1 to n ai phi 1 raised to n minus I. Okay, is it correct? हे कोणाची व्हॅल्यू आहे? phi 1 raised to 1 ची व्हॅल्यू आहे. ओके, ही याची व्हॅल्यू आहे. तसेच phi 2 ची काय येणार? मायनस समेशन ऑफ I running from 1 to n ai phi 2 raised to n minus I. ओके, रन केले फक्त. j इज इक्वल टू 1 साठी हा तुमचा आला, j इज इक्वल टू 2 साठी हा आला, अप टू सो ऑन j रेज टू n, j इज इक्वल टू n साठी काय येणार? मायनस समेशन ऑफ I running from 1 to n ai into phi n raised to n minus I. Okay, is it correct?
Yes, sir.
Hmm. Okay. Now, by elementary row transformation, by elementary row transformation, okay, by elementary row transformation, do not change, do not change the value of determinant. ओके, एखाद्या डिटर्मिनंटवर आपण जर रो ट्रान्सफॉर्मेशन अप्लाय केले तर त्याच्या डिटर्मिनंटवर व्हॅल्यूवर कोणताही चेंज होत नाही. ओके, नॉट चेंज द व्हॅल्यू ऑफ डिटर्मिनंट. ओके, हेन्स वी परफॉर्म दिस ऑपरेशन. ओके, कोणतं ऑपरेशन? एलिमेंटरी रो ट्रान्सफॉर्मेशन. नीट लक्ष द्या. आर एन प्लस ए एन इंटू आर वन प्लस ए एन मायनस वन इंटू आर टू plus an minus 2 into r3 plus up to so on plus a2 into rn minus 1. ओके, नीट लक्ष द्या. आर थ्रो कोणती तुमची? ही आर एन थ्रो आहे. ओके, त्यातली फर्स्ट कोण आहे? ही आर वन, ही आर टू. ओके, चेंज कशात होणार आहे तुमच्या? कुठल्या रो मध्ये चेंज होणार आहे? या रो मध्ये, आर एन थ्रो मध्ये चेंजेस होणार आहे. ओके, आर वन ला एन ने मल्टिप्लाय करायचं आणि ह्याच्यात ऍड करायचं. आर वन ला या ह्याला फर्स्ट रो ला मल्टिप्लाय बाय ए वन अँड ऍड. ओके, सिमिलरली by multiply a2 by r2 then add in the rn. ओके, जर ही तुम्ही एलिमेंटरी रो ट्रान्सफॉर्मेशन परफॉर्म केली तर शेवटी काय येणार आन्सर? Look at here, w dash is equal to, okay, the determinant, this is phi 1, phi 2 up to so on phi n, phi 1 dash, phi 2 dash up to so on phi n dash. Now last row can have, last second row, phi 1 raised to n minus 2, phi 2 raised to n minus 2 up to so on phi n raised to n minus 2, and the last row is काय येणार? फक्त राहणार कोण्यात? a1 राहणार. ओके ओके, a2 पण जातोय तुमचा, पण राहणार कोण शेवटी? a1 हा तुमचा त्याच्यात राहणार. या आनंत रो मध्ये अप टू a2 हे सगळे मायनस साइन मध्ये. ओके, दिस इज इन दी मायनस साइन, हे सगळे मायनस साइन मध्ये तुमच्या. ओके, दिस इज मायनस. ओके, तुमचं ब्रॅकेट मध्ये मायनस आहे. तर हा सगळे समेशन जरी असेल तरी आतले सगळे सिम्बॉल कसे येणार? इंटू मायनस, सगळे मायनस येणार. आपण हे काय करतोय? सगळे त्यात ऍड करतोय. कुठपर्यंत ऍड करतोय? a2 पर्यंत ऍड करतोय, म्हणजे प्लस मायनस गेट कॅन्सल होणार आणि शेवटी राहणार कोण? फक्त a1. a1 इंटू मायनस a1 इंटू phi 1 रेज टू n मायनस 1 हा टर्म राहील, मायनस a1 इंटू phi 2 रेज टू n मायनस 2 इथं हा राहील, अप टू सो ऑन मायनस a1 इंटू phi n रेज टू n मायनस 1. ओके, एनी डाऊट?
No, sir.
बघा, नीट बघा. हे रूल परफॉर्म केल्यानंतर काय येणार? त्याच्यामधले nth टर्म जाईल, anth टर्म जाईल, an मायनस 1 टर्म जाईल, अप टू a2 हे टर्म जातील. शेवटी काय येणार? इथे 1 ठेवल्यावर काय येणार? a1 इंटू n मायनस phi 1 रेज टू n मायनस 1 ही टर्म राहील इथे. ओके, तीच टर्म आपण खाली लिहिली. Okay, with minus sign. Okay, so this gets w dash, okay, which is equal to minus a1 common, taking the minus a1 common from the determinant. So here we get phi 1 phi 2 up to so on phi n, phi 1 dash, phi 2 dash up to so on phi n dash. At last phi 1 raised to n minus 1, phi 2 raised to n minus 1 up to so on phi n raised to n minus 1. Okay, which is nothing but minus a1 into w. Okay, हे तुमचं काय आहे? Rho skin of phi 1 phi 2 up to phi n. So here we get w dash upon w is equal to minus a1. Okay, now integrating from x naught to x, where x is the any point in the interval I. So we get integration x naught to x w dash upon w into dx is equal to minus a1. Sorry, a1 is not the constant here. Okay, it's the function now. So here you get minus with sign x naught to x a1 of t dt. Okay, variable change character. So now tell me what is the integration of this one is log of w with x naught to x. Okay, which is equal to minus integration of x naught to x a1 of t dt. याचं इंटिग्रेशन आपण काढू शकत नाही कारण a1 काय आपल्याला माहित नाही. Okay, so in general we can write as it is. Now which implies that log of w of x minus log of तुमचं काय w of t असेल किंवा काहीतरी असेल हा log of w of x naught which is equal to minus x naught to x a1 of t dt, which implies log of w of x upon to skin of at point x naught, which is equal to minus x naught to x a1 of t dt, which implies rho skin at point x upon rho skin at point x naught, which is equal to e raised to minus x naught to x a1 of t dt. Okay, which implies rho skin at point x, which is equal to rho skin at point x naught into exponential power of minus sign x naught to x e1 of t dt. Okay, any doubt?
No, sir.
What is w of x? Rho skin at double phi 1 phi 2 up to so on phi n at point x, which is equal to exponential to bracket minus x naught to x integration a1 of t dt into rho skin at point x naught at point x naught. Okay, hence the proof. Any doubt? Okay, can we move towards the next point?
Yes, sir.
Now, the next question. Okay, not the theorem. The question is the consider the equation L of y is equal to 0. Okay, which is equal to y double dash plus a1 y dash a1 of x into y dash plus a2 of x into y. Okay, which is second order homogeneous differential equation with variable coefficient, where a1 of x and a2 of x are continuous on some interval I. Okay, काहीतरी interval असेल I. त्याच्यावरती काय कंटिन्युअस असते. अँड लेट phi1 and phi1 and phi1 phi2 and psi1 psi2 and psi1 psi2 be two bases for the solution of L of y is equal to 0. Then show that there is a non-zero constant k such that rho skin at rho skin of psi1 psi2 at point x is equal to k into rho skin of phi1 phi2 at point x. ओके, स्टेटमेंट कळालं का? पहा तुम्हाला सेकंड ऑर्डरचं एक इक्वेशन दिलंय, कोण differential equation दिलाय. Okay, where a1 and a2 are the continuous functions on some interval I. Okay, now the two bases are given to us. Okay, which are phi1 phi2 and psi1 psi2. Then you have to show that there exists a constant k in between their rho skin. Okay, so that is the rho skin of psi1 psi2 is equal to k times of rho skin of phi1 phi2. ओके, कळते का काही? एखाद्या वेक्टर स्पेसला, ओके, मला सांगा, एखाद्या वेक्टर स्पेसला युनिक बेसिस असतं का? प्रत्येक वेक्टर स्पेसला युनिक बेसिस असतात का? बेसिस anyone else? For any vector space,
Yes, sir.
is it the basis is unique? याचे दोन रूट्स येतील, कोणते दोन फंक्शन्स येतील, phi1 and phi2, which is solution. ओके, ते सोल्युशन ऑलवेज लिनियरली इंडिपेंडेंट असतात, हे आपण पाहिलं. सो दिस इज phi1 and phi2 is always linearly independent, and also psi1 and psi2 is always linearly independent. Okay, so this forms the basis of the solution space of L of y. Okay, and also psi1 and psi2 forms the basis of L of y. ओके, समजा एखादा तुमच्या सोल्युशन येत असेल, एखादा दुसराच सोल्युशन तुमच्या एल ऑफ वायचा येत असेल, एक तर तो लिनियर कॉम्बिनेशन ऑफ phi1 phi2 मध्ये असायला पाहिजे, किंवा लिनियर कॉम्बिनेशन इन ऑफ psi1 and psi2 मध्ये असायला पाहिजे. ओके, तर मला सांगा, फॉर एनी वेक्टर स्पेस, इथे सोल्युशन घेतले, फंक्शन घेतले. ओके, फॉर एनी वेक्टर स्पेस इज इट द बेसिस इज युनिक? वेक्टर स्पेसला बेसिस युनिक असतात का?
Yes, sir.
नक्की, नीट विचार करा. एखादा मला वेक्टर स्पेस सांगा, त्याला दोन बेसिस आहेत, दोन बेसिस आहेत. R2 वेक्टर स्पेस आहे?
Yes, sir.
R2 चे स्पेसेस सांगा मला, बेसिस काय फॉर R2? रियल स्पेस
1 0
विथ टू
0
डायमेन्शन,
1.
1 0 and 0 1 हे तुमचे बेसिस आहेत. ओके, का बेसिस आहेत? कारण हे दोन्ही लिनियरली इंडिपेंडेंट आहेत आणि हे स्पॅन करतात R2 च्या प्रत्येक वेक्टरला. ओके, हा एकच आहे का हा मग बेसिस? याच्या व्यतिरिक्त दोन कोणते आहेत का? हे सोडून दुसरे कोणी आहेत
No,
का?
sir.
बघा, कोणतेही दोन लिनियरली इंडिपेंडेंट वेक्टर घ्या, ते ऑलवेज बेसिस असतात. ओके, कोणतेही दोन लिनियरली इंडिपेंडेंट वेक्टर, हे वेक्टर तुमचे बेसिस आहेत का R2 चे? हा तुमचा बेसिस आहे का R2 चा? आहे की नाही? आहे ना? हे
Yes,
दोन्ही
sir.
इंडिपेंडेंट आहे. ओके, मग याच्यामध्ये काय येणार कॉमन? k इंटू 0 1 0 अँड 0 1. ओके, त्याचप्रमाणे घेतलंय. ओके, इथे केस येतो असं नाहीये, पण कोणतेही दोन लिनियरली इंडिपेंडेंट वेक्टर्स असतील फॉर R2, ओके, इट फॉर्म्स दी बेसिस. ओके, कोणतेही दोन वेक्टर, हेन्स द बेसिस इज नॉट युनिक फॉर एनी वेक्टर स्पेस. ओके, कोणत्याही वेक्टर स्पेसला बेसिस युनिकच असतील हे आपण सांगू शकत नाही. Okay, so here the phi1 and phi2 is the basis, and another basis is psi1 and psi2. Okay, if two bases are there, then the relation in between those skins is as it is, as follows: rho skin of psi1 psi2 of x is equal to k into rho skin of phi1 phi2 at x, where k is non-zero constant. Okay, zero असेल तर nothing to prove. Okay, non-zero constant येतो. Okay. Now look at the proof. Rho skin of psi1 psi2 is equal to, tell me what is the rho skin? Hmm.
Psi
काय
1
येणार?
of x, psi 2 of x,
psi1 of x or psi1 psi2. Okay, and second row
psi
is
1 dash, psi 2 dash.
psi1 dash psi2 dash. Okay. Okay, now phi1 is the solution of L of y. Okay, phi2 is the also solution of L of y, and psi1 psi2 is the basis for this L of y solution space. So we can write the psi1 is in the linear combination of phi1 and phi2. इथे तुमचा काय दिलाय नीट लक्ष द्या. phi1 is the solution of this equation. Okay, also psi1 is the solution of this equation, and we have phi1 and phi2 are the basis of this solution space. जे काही सोल्युशन असतील, बेसिस दिलाय म्हणजे काय दिलाय तुमचा हा phi1 तुम्ही लिनियर कॉम्बिनेशन मध्ये लिहू शकता. कोणाच्या लिनियर कॉम्बिनेशन मध्ये? phi1 अँड phi2 च्या लिनियर कॉम्बिनेशन. हा psi2 तुम्ही कोणाच्या लिनियर कॉम्बिनेशन मध्ये लिहू शकताय? psi1 आणि psi2 च्या. ओके, so hence this psi1 we can write is in the linear combination of phi1 and phi2. Why? Because phi1 and phi2 are the basis. It forms the basis. So here we can write psi1 is the linear combination of c1 phi1 plus c2 phi2. Okay. Now similarly for psi2, we can write psi2 is in the linear combination of phi1 and phi2. इथे काय असतील? कोएफिशिएंट वेगळे असतील. c1 c2 असतील तसे नाही. तिथे काय असतील? समजा d1 into phi1 plus d2 into phi2. कळतंय का?
Yes, sir.
ओके. सिमिलरली psi1 dash ला कसं लिहू शकतो आपण? c1 phi1 dash plus c2 phi2 dash. ओके, ह्याची जर व्हॅल्यू साय असेल तर psi1 dash चे काय येणार व्हॅल्यू? ही येणार. ओके, similarly we can write here psi2 dash is d1 phi1 dash plus d2 phi2 dash. Okay, any doubt?
No, sir.
Now expand this determinant. कसे determinant expand करायचं? Look at here. c1 phi1 c1 wait a minute. Okay, and the second row as it is here. Second column d1 phi 1 plus d2 phi 2, and here d1 phi 1 dash plus d2 phi 2 dash plus, okay, into second determinant c2 phi 2 c2 phi 2 dash, the first column, and second column is d1 phi 1 plus d2 phi 2, d1 phi 1 dash plus d2 phi 2 dash. Any doubt? Expand केलं फक्त determinant. Okay, any doubt? Hmm? So now taking c1 common from this determinant, and in the bracket we can write first determinant phi
सर
1.
आपण तिथे सेकंड कॉलम नाही का एक्सपांड करू शकत?
तेच करतोय पुढे, अजून करायचं आधी फर्स्टच करू द्या ना. ओके, सेकंड कॉलम पण एक्सपांड करायचं आपल्याला, C2 कॉमन काढायचं आहे तिकडे. ओके,
ओके
अजून
सर.
काय करायचं, phi 1 dash, and this is one d1 phi 1 d1 phi 1 dash. This is the first determinant, and the second determinant is phi 1 phi 1 dash d2 phi 2, and this is d2 phi 2 dash. Okay, plus C2 common. The first determinant is phi 2 phi 2 dash, and this one is d1 phi 1 d1 phi 1 dash plus determinant C, phi 2 phi 2 dash, and here the d2 phi 2 d2 phi 2 dash. Okay, any doubt? Expand केलं आहे आपण. Okay,
येस सर.
आता इथे नीट पहा. This determinant, एकच मिनिट. व्हॅल्यू 0 घेतली. C2 value. Look at it. What is the value of this determinant? Solve करा काय तर. Phi 1 किती येते? 0 येते.
येस सर.
So here we get C1 into the bracket. We have phi 1 dash d2 phi 2 d2 phi 2 dash. Okay, this determinant is as it is, plus C2 into. Now here, look at here. The value of this determinant is what? Value of this determinant is
0.
0. So here we get only this determinant is as it is. Phi 2 d1 phi 1 phi 2 dash d1 phi 1 dash. Okay, any doubt? Which is equal to C1. Now take d2 common here. D2 into determinant phi 1 phi 1 dash phi 2 phi 2 dash plus C2 d1, the first determinant phi 2 phi 1, okay, and phi 2 dash into phi 1 dash. Okay, so which is equal to C1 d2, the first determinant phi 1 phi 2 phi 1 dash phi 2 dash plus C2 d1, Now interchange this determinantचे रो ट्रान्सफॉर्मेशन किंवा एलिमेंटर ट्रान्सफॉर्मेशन कॉलम ट्रान्सफॉर्मेशन केल्यानंतर त्या डिटर्मिनंटच्या व्हॅल्यूवर काहीही फरक पडत नाहीये. ओके, सो हियर change interchange this column. So here we get phi 1, phi 2, phi 1 dash and phi 2 dash. Okay, any doubt? With minus sign होते. ओके, कॉलम चेंज केल्यानंतर मायनस साइन होतो. ओके, डाउट आहेत का काही?
नो सर.
विच इज इक्वल टू एखादा डिटरमिनंट असेल तर त्याचा रो किंवा कॉलम इंटरचेंज केल्यानंतर साइन मध्ये फरक पडतो का? ओके, सो हियर वी गेट C1 D2 minus C2 D1 in the taking determinant common phi 1 phi 2 phi 1 dash phi 2 dash. Okay, which is equal to C1 D2 minus C2 D1 into rho skin of phi 1 phi 2. And what is the right hand side? Left hand side, rho skin of psi 1 and psi 2 na?
येस सर.
That implies since rho skin of psi 1 and psi 2 are linearly independent. It implies that their rho skin is at point x is not equal to 0 for all x belongs to I. Okay, म्हणजे हा तुमचा काय झाला, नॉट इक्वल टू 0 झाला ह्याची व्हॅल्यू. ओके, this implies that C1 D2 minus C2 D1, this value is not equal to 0. Okay, thus there exists a non-zero constant k which is equal to C1 D2 minus C2 D1 such that the rho skin of psi 1 psi 2 at point x is equal to k into rho skin of. Any doubt? काही डाऊट आहेत का?
नो सर.
If suppose psi 1 psi 2 are the basis, phi 1 phi 2 is also basis for the given differential equation, then we can write rho skin of psi 1 psi 2 is equal to k into rho skin of phi 1 phi 2. Okay, where k is the non-zero constant. Okay, तुम्ही म्हणताल k इकडेच काय येईल, k इकडेही लिहू शकतो आपण. इकडे घेऊन 1 अपॉन k ना, आणि 1 अपॉन k ला काहीतरी c नाव दिलं. ओके, असं येऊ शकतं. ओके, सो रो स्किन ऑफ phi 1 phi 2 is equal to c into रो स्किन ऑफ psi 1 psi 2. का डिवाइड केलं k ने? बिकॉज k is the non-zero constant. ओके, कुठेही लिहू शकता तुम्ही. एनी डाउट?
नो सर.
Okay. The next example on this. Y double dash plus alpha of x into y which is equal to 0, where alpha of x is continuous function on an interval काय दिलं तुमचा होल r minus infinity to plus infinity. Okay, let phi 1 and phi 2 be basis for the solution satisfying phi 1 of 0 is equal to 1, phi 2 of 0 is equal to 0, phi 1 dash of 0 is equal to 1, and phi 2 dash of 0 is equal to 1. Then show that row scheme of phi 1, phi 2 at point x is equal to 1 for all x. Okay. Alpha of x is काय दिलं तुमचा continuous function दिलंय. Again, phi 1, phi 2 are the basis for the solution. कोणाची solution, कोणाची basis आहे इथे? Solution which satisfying these four condition. Then show that row scheme of phi 1, phi 2 at any point x is equal to 1. Okay. समझते का question? Now, the proof. We know that the differential equation y double dash plus a1 of x into y dash, okay, plus a2 of x into y is equal to 0. Okay, now we know that row scheme of phi 1 and phi 2 at any point x is given by exponential by previous theorem a1 of t dt into row, okay, by previous theorem. We have this one. Okay, for the given differential equation, for the given differential equation, for the given differential equation, we have a1 of x. What is the value of a1 of x? What is the value of a1? काय दिलं तुम्हाला differential equation? Y double dash plus alpha of x into y दिलं. What is a1 of x?
0.
What is the a1 of x?
0.
0.
झोपलेत का सगळे?
Ah,
a1 of
sir.
x is 0. लक्ष द्या. And take x naught is equal to 0. Take any point x naught is equal to 0. Okay. So we have row scheme of phi 1, phi 2 at any point x is equal to row scheme of a1 of x जर 0 असेल तर काय येणार तुमचा हा टर्म काय येणार e raised to the power 0. e raised to power 0 असेल तर काय येणार
1.
1 into नंतर 0 1 चाल phi 1 phi 2 of x naught. Okay, at point x naught is काय 0 आहे. So here we get row scheme of phi 1 phi 2 at point 0, which is equal to phi 1 of 0, phi 2 of 0, phi 1 dash of 0, phi 2 dash of 0. Okay, what is phi 1 of 0?
1.
2 of 0, 0. And phi 1 dash, phi 2 dash is 1, 1. What is the value of this one is?
1.
1. Implies row scheme at any point is 1 for all x, that is all x. Okay, any doubt?
No, sir.
हम्म लिहून घेते ना.
Yes, sir.
लिहून घेता घेता बघा डाऊट असतील तर विचारू शकता काही. Variable coefficient. Now we see the non-homogeneous equation with variable coefficient. Okay, here the b of x is not equal to 0. फक्त स्टेटमेंट बघूयात आणि थांबूयात आता. The next point is non-homogeneous non-homogeneous. Okay, equation म्हणजे non-homogeneous differential equation with variable coefficient. बरं का, हेच समजून घ्यायचं होतं. Let b of x be continuous function on an interval I. Okay, we not interval I, and let phi1, phi2 up to so on phi n be the basis for the equation, for the basis for the solution, sorry, solution of L of y is equal to 0. Okay, on an interval I. Then every solution psi of L of y is equal to y raised to n plus a1 of x into y raised to n minus 1 plus a2 of x into y raised to n minus 2 plus up to so on an of x into y, which is equal to
B of X.
b of x. Can be written as psi is equal to c1 phi1 of x plus c2 phi2 of x plus up to so on cn phi n of x plus cast the complementary function plus
Psi P.
psi p. So every solution psi we can write in the form of cf plus pi. We have to prove this one. Okay, where psi p, is a particular solution. Is it correct? करेक्ट आहे का मी लिहिलेलं स्टेटमेंट?
No, sir. B of X
काय ना
पाहिजे.
एल ऑफ वाय इज इक्वल टू बी ऑफ एक्स. हा झोपलेत वाटतं सगळं. अँड C1 C2 up to Cn are constants. Constants. Okay. With psi p is the particular solution of L of y is equal to b of x. And a particular solution psi p, okay, particular solution psi p is given by, any particular solution psi p is given by psi p is equal to summation, same आहे सगळं, u is equal to 1 to n, okay, phi u of x, ओके, आय घ्या के घ्या काही पण घ्या, ओके, इथे व्हेरिएबल आहे यू म्हणजे इथं इंटिग्रेशन एक्स नॉट टू एक्स बी ऑफ टी इंटू रूस्किन यू डब्ल्यू यू ऑफ टी, ओके, अपॉन रूस्किन ऑफ phi 1 phi 2 up to phi n of t into dt, ओके. इथे डब्ल्यू ऑफ टी म्हणजे काय असणार, या रोस्किन मधला युथ कॉलम तुमचा काय असणार, replaced by w of t, ruskin of t, w of phi 1 phi 2 up to phi n of t, okay. So here w of t is nothing but what, इन दी रोस्किन, या रोस्किन मध्ये तुमचा युथ कॉलम जो असेल, जर W1 असेल तर पहिला कॉलम, ओके. क्रॅमर्स रूल मध्ये माहिती आहे, आपण चेक केलंय, सॉल्व्ह केलंय एक एक्झाम्पल, कळते का?
Yes, sir.
एक्झाम्पल घेताना समजेल व्यवस्थित, ओके. सो दिस इज दी ओनली स्टेटमेंट, so there is a proof which we see in the next video, okay, next lecture, okay. Up to here, any doubt?
No, sir.
काही डाऊट असतील तर ते विचारू शकता, okay. Otherwise you can leave the lecture, okay. Thank you for the attending, thank you.